In lesson 7.4, we are still going to be discussing similar triangles. Today we're going to be talking about a few more properties and we're going to apply them. The first one is the triangle proportionality theorem. And the triangle proportionality theorem says that if a line is parallel to one side of a triangle and intersects the other two sides, it divides those sides proportionally. What does that mean? Well, if you take a look at our picture here, we have our triangle ABC, and my line EF intersects it, but EF is parallel to our base side BC. So that line cuts my sides proportionally. Therefore, if I called this cut into segments A and B, and this C and D, I know that the ratio of A over B would be equal to C over D. So I would have a proportion. Let's take a look at that example with some numbers. If you look at example A, we have our triangle LMN, and I can see that my PQ segment is parallel. Now, as I look, it asks me to find side PN. So if I call side PN X, over here, I see my side divided into a ratio of 2 to 5. And so I can use that ratio to solve for x, because my other side should have the same ratio. If I say 2 over 5, I'm going to say that would be equal to 3 over x. Small part over big part, small section over big section. And then, as before, we just use our cross products. Now, we would find that our x value is 7.5. Now that is different than how we would have done it in the previous lesson, because we would have used similar triangles in the previous lesson. So I want to show you something. I could have set that proportion up as if my whole side length here was 7 and I wanted to use similar triangles. This side would be 3 plus x. I could have also set that proportion up as 5 over 7 equal to x over 3 plus x. And we would have found that we would have ended up with the same answer. That would use similar triangles. Now, what happens if I were looking, what happens if I knew that PQ had a length of 10, and I was looking to solve for y? Well, in this case, I would be using a similar triangle. They have the shared angle here at n, and I have some corresponding angles, so I know they're similar by angle-angle similarity. But would you agree, my ratio for y and 10, this would not be a 2 to 5 ratio. That's the mistake a lot of kids would make. They would use 2 and 5 for this ratio. But clearly we know that y needs to be bigger. I'm going to use my triangle to solve this. And so in my triangles, the smaller triangle has a side of 5. The larger triangle has a whole side of 7. So my ratio there is 5 to 7. Equal to, well, in the smaller triangle, the side has a length of 10, and in the larger triangle, the whole side has a length of y. And so, setting up to solve here our cross products, we would find out that y would be 14. Had I used a ratio of 2 to 5, I would have gotten y, I think, I would have gotten y as a length of 4, and that wouldn't have made any sense. So we do have to be careful whether you are using similar triangles to solve or whether you're using the way that the parallel line divides your segment. The converse of our triangle proportionality theorem is also true, that if a line divides two sides of a triangle proportionally, then that proves it to be parallel to the third side. So, for example, if I saw that this segment was cut into lengths of 1 and 3 and 1 and 3, because these are equal ratios, then therefore we would know that our lines are parallel. That would prove DE parallel to GH. So as you look at example B, if they ask me to determine is DE parallel to BC, well, I can just look at my ratios. I can look at a ratio of 8 to 12, and I can look at the ratio of 10 to 15, and I want to know if those are equal. So I can reduce. 4 goes into both of these. 5 goes into both of these. Yes, I can see we have a ratio of 2/3. They must be parallel. Now, the other way that I could have checked that is I could have seen if we had a proportion. And I could have set this up to see, does 8 over 12 equal 10 over 15? And I could have checked my cross products. 10 times 12, 8 times 15. And that also would have let me know that, yes, my lines are going to have to be parallel. And my explanation could be showing the ratio or could be showing my cross products. Either way is fine with me. On the back, we have the proportional parts of parallel lines. This is going to be very similar to what we were just talking about with our triangle. But if you have 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. So here I can see my 3 parallel lines, and I have 2 transversals cutting them. Now, if I go ahead and I kind of label in here, I'm going to label this as A and B and C and D. Now, A, that length is not the same as C. And B is not the same as D because they're cutting at a different angle. But I do have a same ratio here. If I compared the ratio of A over B, that would be equal to C over D. So if this had a 1 to 3 ratio, this would have a 1 to 3 ratio. Let's look at example C. The figure shows parts of a freeway interchange. The raised freeway is supported by vertical parallel pillars. Set up a ratio and solve to find the length of AQ. Okay, my vertical pillars are the parallels. So here are my parallel lines. Setting up a ratio, we are looking to find my length of AQ. Well, I can see here that 30 to 24 really gives me my ratio. And one thing we could do is we could just look at reducing 30 to 24, both reduce, 6 goes into both of them. That tells me my ratio is 5 to 4. So I can use my ratio of 5 to 4 and set up and solve. Or I could leave it as 30 to 24. I'd just be working with larger numbers. Either would be fine. I find a lot of times that kids would leave it in the 30 to 24. If I do the longer segment over the shorter segment, I need to follow suit and do the same thing when I'm solving for x. All of this is in yards, so I don't have to do any converting. And then we would simply look again at solving our cross products. 30x equal to 768, and I would find out that x is 25.6 yards. And again, when you take 768 68 and you divide by 30, you get exactly 25.6. And so that's how I want you to leave your answer. That's an exact answer. I don't need to round that up to 26. Had I used my ratio of 5 to 4, we should still come up with the same answer. The last one doesn't really, our last theorem doesn't have to do with parallel lines, but it does have to do with proportions. So this is called the triangle angle bisector theorem. Okay, well you can see in our diagram that JN is my angle bisector. That's what they're telling me with those little markings right there. It's cutting my overall angle of KJL right down the middle. Now, the way this is worded, it reads as so. An angle bisector in a triangle separates the opposite side into two segments that are proportional to the length of the other two sides. Well, that can be a little bit confusing. One thing that I will tell you is that M does not necessarily mean it's a midpoint. It's not necessarily in the middle. But if the angle bisector separates the opposite side, so this would be my opposite side, it separates it, I'm going to call that A to B, that ratio would be equal to the ratio of the lengths of the other two sides. So if I compared the ratio of A to B, that would be equal to the length of the sides, C over D. Now you would find that you could also set that up, A over C and B over D. That would work as well. You end up with your same cross products. But if we take a look at example D, I can see I have an angle bisector here. My segment SQ is bisecting my angle. S is not necessarily in the middle, so I'm not going to set them equal. But if I set up, this would be my A over B, and this would be my C over D. I can see my ratio of 32 to 40. Now, if I set this up and solve, A over B equal to C over D, before I have to set up my cross products, I would take this and I would reduce, just because it's easier to work with smaller numbers. And so I know that 8 goes into both of them, and we can say that that ratio would be 4 over 5. It just makes it easier to work with. Now, this is going to be one when we set up our cross products and solve. We're going to need to remember that we're going to have to distribute. 5 times the quantity, x minus 2, should be equal to 4 times the quantity, x plus 5. So I find out the value for x is 30. Now I do have to be careful here. That's actually not the final answer. They are wanting the lengths of PS and SR. And so if I take my value of 30 and I substitute it in, I'm going to find that PS is going to have a length of 28 and SR is going to have a length of 35. Again, 28 to 35 has that same ratio, reduced 4 to 5. So I know I've done it correctly. If you have further questions on this, please come and see me.